Hi, my name is Erin Murdoch. I'm an automation engineer at Kendall Electric. On today's Quick Connect video, we're going to highlight some of our mechanical products. Did you know that Kendall Electric has a full mechanical solutions line card? You can count on the same level of service and support for your mechanical systems, the same way you do for your programmable automation systems and controls. Let's think about why this makes sense. You have a motor, an electric motor, and is the purpose of any job just to spin that motor? No, it's to do work. It's to make something move, make something happen. Even though the electrical energy stops there, your job doesn't, and neither does ours. And so that's why today we're going to focus on more than the motor. If you're interested in motor technologies, we will have a subsequent video on those, but you're just going to have to stay tuned. I've done my best to try to break today's content into 3 main points. 1, connecting, 2, supporting, and 3, different methods that we can get from A to B. Let's get started. So the first category is connecting. And by that I mean, what is the motor directly connected to? Typically we'll either see a gear reducer or we'll see a coupling, meaning there's a 1-to-1 ratio direct drive system. When it comes to gearboxes, there is a plethora of options and selection criteria. So many that I'll be making another video just on gearboxes. But let's talk about the ones that are right in front of you. To the left of your screen, you see 2 options for inline planetary units. Moving over, you see right angle units. When it comes to right angles, you've got helical gears, bevel gears, helical bevel gears, hypoid gears, worm gears. All have their own unique benefits and features, and that's why we're here to help analyze your application and get you the best one. So if your motor is not connected to a gearbox, then it's probably connected to some type of coupling. And coupling technology is really cool too. Some applications require rigidity, while others require more flexibility. There's flange couplings, magnetic couplings. I actually have a picture of magnetic couplings on the screen here. There's torque transfer between both surfaces without any contact by using permanent magnets. There's your standard 3-piece servo coupling with different available spiders, that's that red insert in the middle. Different spiders of different durometer, meaning some of them are rigid and others are more flexible for shock absorption or for vibration dampening. Couplings also compensate for misalignment in your machine. Very common is the bellows coupling, also seen here. So the middle section for today's video is called supporting because there are many different ways to support a load. I again tried to break it down into some subcategories. Let's kick it off with bearings. Your standard ball bearing, a plain surface bearing. Now these ones are actually self-lubricating and self-wiping, making them great for your dirty, dusty, grimy applications where you really wouldn't want to gum up your ball bearing. Moving over to the middle pictures, you see your standard tapered roller bearings. Now the ones on the top have your regular flat surface. The carriage on the bottom, in the bottom picture, actually has an integral V. The surface of the bearing is actually a V cutout that rides on a hardened steel rail. Now when it comes to deciding between the two, or between the different size carriages and different bearings, it's all based on the load. Again, radial load, or axial load, or the moment in any direction. Last but not least, we have your average sliders. These range in many different sizes, from the small example that I have here, or the one that I have in the picture, which is something more of this magnitude. And it, again, all depends on the load and the forces that these bearings are going to see. So next up, let's talk about slewing rings or slewing bearings, something you might have seen on the bottom of an excavator or a crane. They're capable of incredibly high moment loads and typically move at a pretty slow speed. They can either be driven by a pinion or by a worm gear. And if you put an electric motor on one, you have yourself a drive system. We could offer the complete solution. And last but not least, as we're talking about supporting, let's talk about structures. Most machines have a type of frame, or they have guards, or doors, or laser enclosures, or workstations. You can get very creative when you're working with extruded aluminum. So the final category that we're going to talk about today is different methods to get from point A to point B, or moving. I broke it down into 2 slides. The first one has our more fundamental mechanical products, where the second slide has some more complicated or application-specific type products. Let's get started with what's on the slide in front of you. To the left, you'll see different options for screws. The top one is an Acme screw, not the most efficient, but probably the most cost-effective. Underneath that is a ball screw, which has more moving parts, is way more efficient, and it's also incredibly easy to back drive, so you'll have to take that into account. Some of the limiting factors for screws are column strength, and critical speed, meaning you don't want to excite the natural frequency of the system and have it resonate out of control. If you wanted to go at a very high speed and a very long distance, we'd probably recommend something more like a belt-driven actuator, seen in the top right, or a rack and pinion system. Both are great for long distances and high speeds. But what about some of our more special products? It wasn't very long ago that hydraulics and pneumatics completely dominated the power transmission industry. That's why I chose the first picture on today's slide. That is a perfect replacement for a hydraulic cylinder. Now, by using an electric motor, you have much more flexibility and control without the risk of expensive air and hydraulic oil leaks. Now, for the middle two pictures, I want you to think about a conveyor system. When I think about conveyors, I always picture a chain and sprocket, but actually, there's a more effective way, without the pinch points. Powered rollers. Powered rollers can go right back into your PLC and be controlled just like a servo motor, giving your conveyor system limitless flexibility. And the last method that I'd like to highlight today for getting from point A to point B is a robot. Just ask us for a product demonstration and you'll see how simple it is to program or integrate right into your Logix project. This is just a highlight of some of our mechanical products. To see our full mechanical line card, make sure to check out the link in the description. Thank you for watching our video. If you'd like more information on today's topic, please talk to your Kendall Electric account manager or automation specialist. You can also visit our website, kendallelectric.com, to find the location nearest you. Stay connected with us by subscribing to our YouTube channel or following us on Facebook or LinkedIn. Thank you, and see you on our next Kendall Quick Connection.